To solve a quadratic equation graphically, we just need to recall our methods of graphing a quadratic equation and recall our methods of solving a general equation from a graph. First of all, a quadratic equation is an equation that can be put in this general form ax squared plus bx plus c equals 0. Basically, we recognize these as being equations in which the highest power is an x squared. So in this case, what we have is x squared minus 2x minus 8 on one side of the equation. I'm going to write that out as y equals x squared minus 2x minus 8 as one of the two graphs we need to establish. And on the other side of the equation, we have simply 0, and therefore the other equation I want to graph is y equals 0. Well, y equals 0 is an easy one. This is just a horizontal line, which happens to be the same as the x-axis. So let's focus on the parabola first, the quadratic function. This is in general form, so we're going to start by finding the vertex using the vertex formula. Remember that h equals minus b over 2a is the x-coordinate of the vertex. So in this case, my a is equal to 1 and my b is equal to negative 2. And therefore my h is minus negative 2 over 2 times 1, which comes out to be positive 1. K I find by plugging h into the formula, the quadratic. So that's 1 squared minus 2 times 1 minus 8, which is 1 minus 2 minus 8 is negative 9. Therefore, my vertex is down here at the point 1, negative 9. I now recognize that this parabola opens up because the leading coefficient is positive, and that it has no stretching or shrinking, so this should follow the same exact pattern as the graph of y equals x squared, which means it'll pass through the points 1, 1, 2, 4, and 3, 9, all plotted relative to the vertex instead of relative to the origin. Then I can reflect all of these points back about the line of symmetry to get my parabola. For a review of this method of graphing quadratic functions, I suggest section 3.1, the quadratic functions section. This is my parabola. Then I need the line y equals 0, which is the x-axis. And I'm going to look for the intersection points. And remember that we're only interested in the x-coordinates of these intersection points because I'm solving an equation in x. It looks like I have one here at negative 2, another one here at positive 4, and therefore my solution set is just the two values, negative 2 and positive 4. I feel like I can't emphasize enough that the bracket type really matters. Remember that if you use square brackets, this really means the interval of all values between negative 2 and 4. Those are not all solutions to this. If you use parentheses, then that could mean one of two things. That could either mean, again, the interval of values between negative 2 and 4, not including the endpoints, or it could mean the ordered pair negative 2, 4, where negative 2 is an x and 4 is a y. But these are both x values, so that's not correct either. These set braces really mean a list of values. Just the values negative 2 and positive 4 are in this set. Note that these two values, when I say these, I mean solutions to f of x equals 0, because that's the equation we just had, was in the form a quadratic function on one side is equal to 0. Solutions to f of x equals 0 are the x-intercepts of the graph, and they are what we would say are the real zeros of the function. Remember that a zero is an input that makes the output equal to 0. So we tie these ideas together very often. If we have a graph and we're asked something about real zeros, we know that the real zeros are the same as the x-intercepts, so we go straight for the x-intercepts, right? We want to be able to go kind of in a triangle among these three ideas as needed, right? Solutions to f of x equals 0, x-intercepts of the graph, and real zeros of the function. I should say real solutions. We haven't really talked about any non-real solutions yet, but they're going to come up right away. So real solutions to f of x equals 0, x-intercepts of the graph, and real zeros of the function are all the same.